Hello friends, welcome back to our third video of the video series on IRC 78 Part 2, the limit state design of foundation. In our previous video, we discussed on the pile foundation which were under compression, and I would like to add few more points in the section of resistance factor. So first thing, for resistance factor in piles resting on soil, we come to the very first method, that is by calculation using the ground parameters obtained from site investigation. And here we says that for special vehicle loading, the GR2 to be reduced by 15%. And secondly, if we move on to the group action for compressive loads, for SV loading, ground resistance factor to be taken as 1.2. So that was it, and we'll move on to the next section of the video. So we'll continue our discussion with piles under tension. So here we have two cases. One is the ultimate limit state and second is the serviceability limit state. So again, in ultimate limit state, we have three factors: the load factor, the material factor and the resistance factor. For load factor, IRC 78 refers to the table B4 of IRC 6, and it says additionally that for permanent action resisting tensile force, factor shall be taken as 1. Means if permanent action is causing compression on the pile, the factor shall be 1. Whereas in case of permanent action increasing the tensile force, we shall refer to the table B4 of IRC 6. And for buoyancy, the factor shall be 1. For material partial safety factor, we need to refer to the table 2 and table 4 of IRC 78. Now coming on to the resistance factor for piles in soil. So for single and group pile, we'll continue with the single pile. So there are three methods, that is by calculation from ground parameters obtained from site investigation, by carrying out a pull-out test, or by calculation from ground profile test, example cone penetration test. So the characteristic shaft resistance to be calculated as per Appendix 5 of IRC 78. Now for this, the partial factor for resistance for tensile or the uplift in the soil, we need to refer to the table 10. The GR5 to be used for combination 1, GR6 for combination 2, GRS for seismic, GRA for accidental with a model factor of 1.5. For compression, this model factor was 1.2. The second method is by carrying out a pull-out test, and we see again the methodology or the concept of correlation factor. Based on our number of tests, the correlation factors reduces. So the characteristic capacity of pile QC shall be the minimum of mean measured capacity divided by CR3 or the minimum measured capacity divided by CR4. In this case, for piles under tension, the CR3 and CR4 are to be modified with a factor of 1.1, and the partial factor for resistance, the table 10 shall be followed here, and the model factor shall be taken as 1. So in other way, we can say that the CR3 or CR4 remains the same if model factor is 1.1. Moving on to the third section, that is by calculation from ground profile test, example the cone penetration test. The code says to refer clause 7 of appendix 5 of IRC 78 for calculation of shaft tensile resistance, and based on the number of tests we need to refer to the table 6 for correlation factor. Again, these correlation factors are to be modified with a factor of 1.1, and very similarly the partial factor for resistance given in table 10 shall be used with model factor as 1. Moving on to the group action of piles under tension. So it says the total uplift resistance of a single pile is equal to the tensile resistance of the shaft or the base. In this case, the base is not applicable. So tensile resistance of shaft plus weight of pile. For group resistance, we need to follow the clause 709.3.6.3 of IRC 78 part 1, and the material factor shall be set 1 of table 2. The load factor is equal to 1 for weight of soil and pile, and the resistance factor, there is no additional resistance factor given for the group action. So but it says that the tensile resistance of a group shall be less than equal to number of pile into the tensile resistance of a single pile. So this was a short video. We'll cover the piles in rock or the intermediate soil when we cover the piles in rock or intermediate soil in compression. Thank you.